I recently purchased the pi-Stomp V3 kit from Treefall Sound. It's a DIY open source stomp box based on the Raspberry Pi 5 and the open source mod pedalboard. If you just purchased one of these kits and are looking for build instructions, I've got another video on my channel which you can follow along with while you're building your pedal. The rest of this video is going to assume that you've already built your pedal and have it working. When you load up your pi-Stomp for the first time, you'll land on a default pedal board that's shipped with the device. These pedal boards live in the Treefall Sound GitHub organization. You can switch pedal boards by selecting the pedal board text, using the navigation encoder, and single clicking to see a list of pedal boards on the device. Select one and click again to switch to it. We can control a lot of aspects of the pedal board directly on the pi-Stomp. You can see that this pedal board controls the mix of the Modulate plugin and the drive of the two-board plugin using the rotary encoders called Tweak 1 and Tweak 2, and the foot switches are mapped to bypass or enable some of the effects. So it's just like stomping on the stomp box if it was a real pedal. We can also use the navigation encoder to toggle individual effects that might not be mapped to a foot switch. Deeper customization, the ability to tweak any parameter, add new virtual stomp boxes, and even create entirely new pedal boards can be accessed via Mod UI using your web browser. If you follow the software installation instructions, this will be available at pi-Stomp.local. This is an open source pedal board built by the folks at Mod for their Mod Dwarf pedal board. Any LV2 plugin that can be compiled on Linux ARM64 can be used here, and the default installation comes with hundreds of usable effects. Here's what the pedal board we have loaded looks like. Keep in mind that unlike your physical pedal board, audio travels from left to right in Mod. So for example, I can change the cabinet simulation, add new effects, or even change the way the pedal board is routed, and these changes happen in real time, making it pretty intuitive to dial in new effects. Mod also has the concept of snapshots, also called presets, which represent saved collections of effect parameters. Switching between snapshots is much faster than switching between pedal boards, so they're useful to dial in settings for different parts of a song. By clicking on one of these snapshots in the web UI, the effect parameters take place immediately. You can also switch between them using the pi-Stomp foot switches. A and B by default will go to the previous and next snapshot respectively. This is customizable on a per pedal board basis, and we'll get into how to do that later by modifying some config files on the device. Now, before we go modifying the software, the key to understanding the pi-Stomp is that the Mod platform is the engine of the device. It has total control over audio and MIDI processing, while the pi-Stomp software itself is mainly an interface on top of it. When you interact with the pi-Stomp, Python code running on the device sends messages to the Mod pedal board. In our current pedal board, short pressing the foot switches or rotating the encoders sends MIDI CC messages. Selecting pedal boards, snapshots, and toggling effects sends HTTP requests to the Mod UI's API server. Going in the other direction, pi-Stomp also needs to keep track of the changes we made off the device. Whenever we navigate to a different pedal board or save the current one in Mod UI, it writes to a last.json file, which stores the name of the currently selected pedal board. The pi-Stomp software watches the modification time of this file and then uses that information to synchronize the LCD screen with the mod state. You might have noticed earlier that if you change snapshots on the web interface, the pi-Stomp interface doesn't update. This is because snapshot changes aren't reflected in the last.json file. In fact, they aren't even written to disk in a separate file called snapshots.json until the pedal board itself is saved. But this is a one-way problem because when we change snapshots on the pi-Stomp, the Mod UI interface correctly updates. One thing I noticed while playing around with the pedal was if I had two browser tabs open, they kept in sync properly. If we could tap into that mechanism, we could fix the bug. So I started looking into how this works behind the scenes. The pi-Stomp and Mod UI codebases are both freely available, so I cloned them and started looking through the code. It turns out there's another API that Mod UI exposes other than the REST API, Websockets. I added a simple handler to the WebSocket instance in the browser's developer tools. I saw a stream of messages coming in, including a pedal snapshot message that contains the name and identifier of the newly selected snapshot. Now, if we can get this stream of messages in the pi-Stomp, just like the browser pedalboard interface does, we can ensure we're always synchronized with the pedalboard's current state. After playing around with the protocol for a while and observing its behavior, I learned that it expects two things of any connected WebSocket client. It must respond to ping messages with a pong, a standard liveness check, and any data-ready messages must be immediately echoed back. Otherwise, real-time gain feedback and such breaks on every connected WebSocket client. This includes ModUI. With the WebSockets Python library as well as some nice typed data classes, we can make short work of implementing this feature. There were a couple edge cases to deal with, however. For example, the loading end message is sent by ModUI once a pedalboard is loaded. This contains the snapshot ID because the pedal snapshot message is not sent when the pedalboard is first loaded. My intention was to remove the last.json monitoring completely and rely entirely on WebSockets, but unfortunately, this message doesn't contain the actual pedalboard name, further complicated by the fact that this event is fired long before the last.json file is updated. My solution was to not immediately apply the snapshot ID returned from the loading end message, instead combining it with the existing last.json observer and only applying the snapshot ID that we get once we have the new pedalboard name. I also took the opportunity to refactor the observer logic into its own file. It's time to test our fix, and fortunately it's really easy to deploy new code to the device. We can SSH in using pi-Stomp at pi-Stomp.local. After using the password I set up during software installation, I copied my SSH public key over to the device so I could log in without typing it every time. Now, it's just a matter of SCPing the changed files and restarting the service to pick up the changes. I made a quick script to do this, which then restarts the service and confirms that there were no errors on startup. So let's confirm that our fix is working. I'll load up ModUI and change the currently selected snapshot. Once we do, we can see that it's correctly updated on the pi-Stomp, even if it takes a little bit of time to get there sometimes. Off screen, I did some more navigation through the pedalboards and snapshots to ensure we didn't introduce any new bugs, and it looks like things are working just fine. It was at this point that I wanted to start using my expression pedal, which I wired up using header pins on the pi-Stomp's mainboard. Unfortunately, this didn't work. I tried assigning the pedal to one of the effect parameters using Mod's MIDI learn capability, but nothing happened when I pushed the pedal. Switching back over to the source code, I learned that the pi-Stomp refers to inputs like the expression pedal as analog encoders. Looking at the default config file in the pi-Stomp repository, it becomes immediately clear why things aren't working. It's disabled by default as commented out, so let's get it working. SSHing back into the device and navigating to the home data config directory, we can see a default config.yaml file, which is called default config because these settings can also be overridden on a per pedalboard basis. Pedalboards live in directories in the home pedalboards directory, and you can put a config.yaml file in each one with the same structure to override the defaults. We'll look into per pedalboard configuration a bit later, but I want my expression pedal to work on every pedalboard, so we'll load up default config.yaml. Uncomment the appropriate section, which is already set up to work with the V3 Hardware's expression header pins. You can see that it's sending a MIDI CC 75, and in the default config, that's on MIDI channel 14. So let's restart the pi-Stomp service and check if the expression pedal is working now. Back in the mod pedalboard, we'll try that MIDI learn functionality again. And once we press the foot switch, we can see that it's working. Here I've just mapped the control to a volume control, but you can control any single parameter this way. We can confirm that it's mapped to channel 14 CC75 as expected. I played around for a while, building pedalboards and assigning my expression pedal to various parameters. I was having a lot of fun, but I found it to be a little restrictive. One of the constraints of Mod Pedalboard is that each MIDI CC can be mapped to at most one parameter. So I can't, for example, blend between two signal chains with a mixer at the same time as changing drive, gain, or boosting different frequencies. I mainly play bass, and this is pretty important to avoid losing low end as you stack effects. I'd already set up some great snapshots on my pedalboard, and then it occurred to me, what if I could blend between two snapshots using the expression pedal? That felt like a way to extend the ecosystem without radically changing its fundamentals, and it would be immediately useful to anyone else who'd already dialed in some great sounding presets. So here's the plan. Let's have the pi-Stomp software create some virtual snapshots that engage this new blend mode feature. To do so, we'll extend the configuration format with a new blend snapshot section where we can choose the analog input, the expression pedal, or one of the tweak encoders maybe, as well as the snapshots to blend between. When we load up a pedal board with blend snapshots configured, we'll modify snapshots.json to reflect the current configuration so the snapshots are selectable just like any of the other ones. If you've ever played around with gradients in CSS or something like Photoshop, you'll have heard of the concept of a stop. It's essentially a keyframe with the current parameters of the gradient at that position, which is usually red, green, and blue. The non-keyframe parts of the gradient have values that are generated by interpolating between the values of the keyframes. Blend mode works exactly the same way. Each snapshot we reference in our stops defines values for effect parameters, and we can simply find out the difference in parameter values between the snapshots and blend between them based on the value of our expression pedal, allowing us to control many parameters at once. The last piece of the puzzle is how to actually update these parameters on Mod Pedalboard. Luckily for us, the WebSocket API has us covered. We can send a param set message with the identifier of the parameter we're changing, which we found when we parsed snapshots.json and performed a diff between the snapshots we're interpolating between. I was initially worried that ModUI wouldn't be able to keep up with a continuously varying parameter like this, but that fear was unwarranted. After updating our pedalboard's config to interpolate between the cleanish and full fuzz snapshots, deploying the new code to the pi-Stomp, and restarting the service, let's see if our system is working as designed. It came up with the snapshot name we put in config.yaml. That's a good start. It means we're updating the snapshots.json file correctly. And when I wiggle the expression pedal, I can see all of the parameters that differ between the two snapshots I defined getting updated in real time. So let's give this a spin. This is what I've always wanted in a pedal. Something that sounds great and lets me tweak my setup so I can focus on making music. If you haven't played with an expression pedal before, it's a great way to get some new inspiration and can breathe new life into riffs you've played hundreds of times before. If you're interested in trying out this code on your pi-Stomp, take a look at the blend mode PR in the video description. Possibilities with this pedal are literally endless. In the next video, I'm going to show you how we can customize the software even further. We can make it interface with external USB MIDI devices like the Source Audio C4, extend the pi-Stomp's UI to add clipping indicators, show the current state of analog inputs, and much more. Thanks for watching, and make sure to subscribe if you want notifications when that next video is live.